In traditional software engineering, a function is a contract. Give it the same input, and you get the exact same output every single time. Frameworks like Jest and Cypress are built to enforce this contract. They rely on strict equality. If the output string matches the expected string, the test passes. But LLM agents operate on probability, not fixed logic. They are stochastic and context-dependent. Even with identical prompts, the model might vary its phrasing, token sampling, or framing. This terminal window shows the result of forcing deterministic tests onto stochastic models. The AI is semantically correct, but the assertion fails here at the expect output to be statement. Rigid string matching cannot account for varying expressions of an idea. Applying these strict assertions to language models results in a high volume of false negatives. The system flags errors not because the AI failed, but because the test was too brittle to understand the answer. This creates a vulnerability in AI engineering known as the silent regression, a failure that triggers no alarms in traditional QA frameworks. These glowing chains represent hidden fragility. Changing summarize to briefly summarize seems cosmetic, but that single word alters output structure, breaking applications while code remains unchanged. Git tracks changes in code, but it cannot track the shifting semantics of a prompt. To catch these regressions, the testing paradigm itself must become semantic aware. The solution is to introduce an independent, higher capability LLM into the CI/CD pipeline to act as a judge. This architecture, popularized by Zhang et al., uses a second model to review agent outputs for meaning rather than exact characters. In the CI gate workflow, the target agent receives the input and generates its response as usual. That output is then passed to the judge model. Instead of a pass-fail Boolean, the judge returns a weighted numerical score based on correctness and relevance. This transforms the evaluation process. It replaces brittle, handwritten assertions with an automated semantic review that is ready for production scale. To prevent the judge model from hallucinating its own criteria, it must grade against objective, measurable metrics rather than subjective quality. Most engineering teams adopt the RAGAS framework, which uses 3 core metrics to evaluate any RAG pipeline. The first is faithfulness. This measures if the answer is derived only from the provided context, providing a direct measurement of the hallucination rate. Next is answer relevance. The judge checks if the response directly addresses the user's query, penalizing outputs that are tangential or overgeneral. The third is context recall. This confirms that the agent actually retrieved and used the correct source documents, which is the most common point of failure in RAG systems. These metrics form a scoring matrix. For every prompt execution, the judge calculates percentages for each, arriving at an aggregate score that defines the health of that specific test run. Grounding the judge in these foundational parameters ensures that the evaluation remains technically rigorous. Writing 200 manual edge case prompts is not scalable for engineering teams, yet a small sample size is insufficient to catch latent regressions. Synthetic data generation solves this by using a model to auto-produce realistic test inputs from your specific domain schema. Starting with your schema, the LLM generates question variants based on production log patterns, varying the difficulty and ambiguity of the inputs. It then generates ground truth reference answers, establishing the baseline context the judge will use for comparison. Finally, the agent is run against these cases, scored by the judge, and the results are stored in a persistent evaluation dataset. Because even a single token change in a prompt can trigger a cascade of structural shifts, automation is essential. It allows you to rerun the entire test suite on every version change to ensure stability. A robust guardrail strategy splits this evaluation into 2 parallel modes. First is offline staging. This is your quality gate. Full evaluation suites run against hundreds of synthetic tests before any code is deployed. If the metrics regress, the release is blocked. However, staging datasets cannot predict every possible user behavior. Distribution shifts in production often outpace static test suites. This requires real-time evaluation. A lightweight judge model samples live, in-flight traffic to monitor the actual output quality being delivered to users. The moment quality thresholds are breached in production, the system triggers an alert or initiates a rollback to a known stable state. To implement this, you must instrument your agent for logging, integrate the judge model into your CI, and continuously update your synthetic test suites. The transition to semantic evaluation represents a shift in how AI systems are maintained. Cognitive test engineering is the mechanism that allows for the deployment of reliable, production-grade agents.